Hello Geometry, this is lesson 73. Our objective is how do you find the angle of elevation and depression, and I guess more really be like how do we use the angle of elevation and depression to find different lengths. First of all, I guess it's to find that an angle of depression is whenever you're looking straight out horizontal and then you're looking down from that. So like an airplane looking straight out, that angle of depression would be how much they came down. So like maybe look at this person down here. An angle of elevation is whenever you're looking straight out and then you raise your eyes up, you elevate your eyes versus depressing them like you would depress a button. That's what we call an angle of elevation, how much you raise your eyes. Also remember SOHCAHTOA, your sine, cosine, and tangent of side lengths, which we already studied about, because you need to remember those as we go through this lesson. Here's example 1, angle of elevation. Angle of elevation. Use the angle of elevation between the kite and the child to find the horizontal distance between the kite and the child. So what we're looking for is this length between the child and the kite, straight horizontally. We know that the angle of elevation is 36 degrees, and we know that the kite string is 80 feet. So we're wondering how far laterally, like if you wanted to come right here to catch the kite, how far would you have to move this way? So we know that this is the adjacent side, this is the opposite side, and this is the hypotenuse. So then we need one that uses the adjacent and the hypotenuse because that's the one we're looking for and the one we have. So we're going to say cosine of 36 degrees is equal to the adjacent of the hypotenuse, so x over 80. I'm going to solve this for x, so I'm going to multiply both sides by 80. So it means it's going to be 80 times cosine of 36 degrees. It's going to give that x. I'm going to use a calculator. And we get x to be approximately 64.7. And since this is in feet up here, my answer here is going to be in feet as well. So I'd say about 64.7 feet, or you could say maybe 65. Example 2 says angle depression. The pilot in a plane cruising at 33,000 feet sees a lake. If the angle of depression from the plane to the lake is 30 degrees, how far is the plane from the lake? So notice this angle from here to here is 30 degrees, and we're wanting to know the distance from here to here. So I'm going to call that length x. Now, we can kind of look at this several different ways. If we want to know this one, we're going to need to find one of either A or B, these angles. Well, we know that this angle right here is 90. Since that one's 30, that means A would equal to 60 degrees. That one's nice, so that means B would also be 30 degrees, remember, because these two would be parallel. So those would be opposite interior angles, so 30 degrees. So you could use either one. I'll use this 30 degrees down here for angle B. So then this is going to be opposite, and this is going to be the hypotenuse. So that is going to be sine of 30 is going to equal to opposite of the hypotenuse. So multiply by x. So I'm going to have x sine of 30 is equal to 33,000. And divide by sine of 30. This part just becomes 1, so I get x is equal to 33,000 divided by sine of 30, which comes to be 66,000. And since this is in feet, we would say feet. Now, another way you could have done that is if you wanted to use this 60 degrees here. Remember here, this is still going to be the hypotenuse, but this is now going to be the adjacent. So if you wanted to, you could have also said cosine of 60 degrees is equal to 33,000 over x, and solved it similarly except for using cosine of 60 instead of sine of 30, because these two values actually are exactly the same. So you got the same answer of 66,000 feet. Alright, One more here. It says a window washer is working 60 feet above the ground. About how far away is each person pictured at street level? So let's go with this person B first. Don't ask me why I picked person B first. So we have this triangle, that's 70. I know this length over here is 60. I'm looking for this one. This is opposite the angle, and this is the hypotenuse. So this is going to be sine of 70 is equal to 60 over x. We're going to solve it similarly to the one we just did before, multiplying by x and dividing by sine of 70. So x is equal to 60 over sine of 70. So x is going to be approximately equal to 63.85 or 63.9. 63.9. Again, this would be in feet. So to person B, now looking at this triangle here, again this is 60, this is now 40 degrees, so I'm going to set up pretty much the same way. Sine of 40 is equal to 60 over x. So I guess I should have used y over here, huh? My fault. So now solving for this, you get x is equal to 60 over sine of 40, which is 93.34 feet to person A. Alright, your homework is on page 486. You can do the lesson practice, the 73s, and then 7 more of your choice.